This is the review for 6.3 to 6.6. What you're doing today is nothing new. You're just reviewing 6.3, 6.4, 6.5, and 6.6 because you need to know how to do all these skills for 6-7. So take a look at the first couple questions. The first couple of questions all involve translations. Remember that a translation slides a picture. We're looking to see what the rule is. So you want to say how many do you go left or right, and then how many you go up or down. So remember that you always go from the letter to the same letter prime. So from A to A prime. So we need to count 1, 2, 3, 4, 5, 6 places to the right. So we're going right 6. That gets us to here, and then we're going down 1, 2, 3. So right 6, down 3 would be our rule. If you said it the opposite way and you said down 3, right 6, that's fine as well. All right. Take a look at question number 2. Again, we want to go from A to A prime. So we're going 1, 2, 3, 4 places to the left. So we're going left 4, and then we're going up 1. Again, if you said up 1, left 4, that's fine as well. In question number 3, you need to draw 3 things. You need to do 3 things. You need to draw the new translation. You need to label it with primes, and you need to write down the coordinates. Remember that when you write down coordinates, coordinates are always written x comma y. Your x value is how many you go over. Your y value is how many you go up or down. So in A, we need to go left 4 and down 1. So starting at A, left 4, 1, 2, 3, 4, down 1. This is my new A prime. Left 4, 1, 2, 3, 4, down 1. This is my new B prime. Left 4, 1, 2, 3, 4, down 1. This is my new C prime. Connect the dots to form your picture. When you draw your new picture, it should be the same exact size and same exact shape. So notice that it's 2 wide and 2 wide, 4 high and 4 high. Make sure that you remember to label them all with primes. Now we want to figure out what the coordinates are. We want to start counting from that green dot right in the middle. It's the coordinates of the new shape. So A prime is over to -4, up to +4. B prime, starting in the middle, over to -4, up to 0. C prime, over to -2, up to 0. So we drew it, we labeled it with primes, and we wrote down the coordinates of the new shape. Let's do another one. This time we're going right 3, up 4. So starting at D, right 3, 1, 2, 3, up 1, 2, 3, 4. This is my new D prime. Starting at E, 1, 2, 3 to the right, up 1, 2, 3, 4. This is my new E prime. Starting at F, right 3, 1, 2, 3, up 1, 2, 3, 4. This is my new F prime. Again, connect the dots. Your shape should be the same exact size, same exact shape. Notice 2 wide at the top, 2 wide at the top, 3 tall and 3 tall. We labeled it with primes. Again, your first number is how many you go over. Your second number is how many you go up or down. So D prime, starting in the middle. Remember, we always start counting from right in the middle at 0, 0. We're going over 0, up to 3. E prime, over to 2, up to 3. F prime, over to 2, up to 0. So those were translations. Now we're doing dilations. With dilations, what you need to do is you need to multiply by the scale factor. This one says that it has a scale factor of 3. That means we are multiplying by 3. We want to take each of these numbers for our coordinates and multiply them by 3. So 2 times 3 is 6. 1 times 3 is 3. I like to put them right underneath it to organize them better. 0 times 3 is 0. 1 times 3 is 3. 0 times 3 is 0. -2 times 3 is -6. Now we want to graph both triangles. 2, 1. Remember, we always start counting from right in the middle at 0, 0.
2, 1, over to 2, up to 1. 0, 1, over 0, up to 1, and 0, -2. This is our original triangle. Now we're going to graph our new triangle. Over to 6, up to 3. Over 0, up to 3. Over 0, down to -6. Connect the dots. Notice that our triangles overlap a little bit. That's okay, that will happen. It's the same sort of shape of the triangle, just one is bigger and one is smaller. How much bigger is it? Well, it's 3 times bigger. All right, it's 3 times bigger because we multiplied everything by 3. Notice that it was 2 wide at the top, and now it's 6 wide. 2 times 3 is 6. Notice that it was 3 tall, and now it's 3, 6, 9 tall. So everything's being multiplied by 3. In this one, you don't have to label because they did not label the points as like A, B, and C. Let's do another one. This time, again, this time we have a scale factor of 3. So we want to multiply by 3. Always check and make sure what your scale factor is. If you had a scale factor, for example, of 1/2, you would multiply everything by 0.5. If we had a scale factor of 1/3, we'd multiply by everything by 0.3. If we had a scale factor of 2, we'd multiply everything by 2. Again, this time we have a scale factor of 3 because it's the same directions. So -2 times 3 is -6. 0 times 3 is 0. -2 times 3 is -6. -2 times 3 is -6. 1 times 3 is 3. 0 times 3 is 0. Our original triangle. All right, I'm going to do the original one in red here. So over to -2, we always start graphing from right in the middle. Over to -2, up to 0. -2, -2, and 1, 0. So here's our original triangle. Notice that it's 3 wide and 2 tall. So now we're going to graph our new one. -6, 0. Over to -6, up to 0. -6, -6. And then 3, 0. So here's our new triangle. Notice that this blue triangle is pointed in the same direction. It looks the same, it's just bigger. How much bigger? It's 3 times bigger. Notice that now the height on the side is 6. Before it was 3. 2 times 3 is 6. Notice that it was 3 wide and now it's 9 wide. All right, everything got multiplied by 3. Again, you don't have to label on this one because they weren't labeled. Moving on to reflections. Remember that a reflection is a mirror opposite image. You want to count how many places to that line and then count the same number of places away from the line. So in this one says we want to do a reflection over the x-axis. This is your x-axis. I would always make that line darker, whatever it is. You want to count how many places to that line and then count the same number of places away from the line. So when we're taking a look at this, A is 1, 2, 3, 4, 5 places to the line. 1, 2, 3, 4, 5 places away from the line. This is A prime. B is 1, 2 places to the line, 1, 2 places away from the line. That's B prime. C is 1, 2 places to the line, 1, 2 places away from the line. The C prime. Connect your dots. Notice that we have that flipped opposite mirror image. We could fold our paper right along that line and those two triangles would match up perfectly. They should be the same size, the same shape. Notice 2 high and 4 wide, 2 high and 4 wide. When you go to write your coordinates, remember your first number is how many you go over. Your second number is how many you go up or down. So we always start counting from right in the middle at 0, 0. So A prime is over to 1, down to -5. B prime is over to 1, down to -2. C prime is over to 5, down to -2. So that was a reflection over the x-axis. In the next one, we're doing a reflection over the y-axis. I would make that line darker. This is the line that you're counting to and the line that you're counting from. So D is 1, 2, 3 places to it, 1, 2, 3 places away from it. This is D prime. E is 1, 2 places to it, 1, 2 places away from it. This is E prime. F is 1, 2, 3, 4 places to it, 1, 2, 3, 4 places away from it. Is F prime. Connect the dots. And there's your new triangle. Again, same size, same shape. It's just that flipped opposite mirror image. You should be able to fold the paper right along that line, and those two triangles would match up perfectly. When we go to do our coordinates, we always start right in the middle at 0, 0. Over to -3, up to +5. Over to -2, up to +1. And F prime, over to -4, up to +1. So again, reflection is that mirror opposite image. Sometimes you'll be given a reflection just over a random line. Notice that this random line is drawn there already for you. You want to count how many places to that line, how many places away from it. So G is 1 place to it, 1 place away from it is G prime. H is 1, 2, 3 places to it, 1, 2, 3 places away from it is H prime. I is 1, 2, 3 places to it, 1, 2, 3 places away from it is I prime. Connect the dots. There's your flipped opposite mirror image. Remember, it needs to be able to fold right along that line and those two triangles to match up perfectly. So doing your coordinates, you always start from right in the middle at 0, 0. G prime is over to 1, down to -1. H prime, over to 1, up to 1. And I prime, over to 5, up to 1. So that was over a random horizontal line. You might have ones that are random vertical lines as well, where you do the same thing. Count how many places to it, count that same number away from it. The next type of question is a diagonal line. In a diagonal line, you need to count, all right? Let's pretend that's our diagonal line. You want to count corner to corner to the line, corner to corner away from the line. So J is 1 block corner to corner to the line, 1 block corner to corner away from the line is J prime. K is 1, 2 places corner to corner to the line, 1, 2 places corner to corner away from the line is K prime. L is 1, 2, 3 places corner to corner to the line, 1, 2, 3 places corner to corner away from the line is L prime. Connect your dots, and there's your new triangle. Again, you want to count corner to corner to the line. If the diagonal line was going the other way, we'd count corner to corner this way. So anyway, doing our coordinates, starting in the middle. J prime is over to 1, up to 3. K prime is over to -2, up to +2. L prime is over to -2, up to +4. And for the last question, we are going to do a rotation. Now, there's 3 different types of rotations. I would suggest when you go to do a rotation that you do the coordinates first, all right? I would do the coordinates first. Find all 9 of them first, then go back and graph them all. So a 90-degree clockwise rotation. When you have a 90 degrees clockwise rotation, you need to turn your paper 90 degrees clockwise, all right? Remember that positive numbers always go up and to the right. Negative numbers always go down and to the left. So when I'm looking at this one, I'm looking at A prime, B prime, and C prime. A is over to 5, down to 4, but it's not down to 4. It's really over to 5, down to -4, because anytime that you go down, down is negative. B is over to 1, down to 4, but it's not down to 4. it's down to -4, because anytime you go down, down is negative. C is 1, 1, but it's not 1, 1, it's 1, -1, because anytime you go down, down is always negative. The next one is a 180-degree rotation. So when we take a look at this one, oh, my paper isn't going to allow me to do that. So when we go and do this one, it is upside down. All right. When we take a look at it upside down, we are looking, all the numbers are wrong. So now we're going to do A double prime, B double prime, and C double prime. So where is A really at? It looks like it's at 4, 5, but it's not at 4, 5. Anytime we go to the left is really negative. And anytime we go down, down is negative as well. So over to -4, down to -5. B looks like it's at 4, 1, but it's not. It's over to -4, down to -1. Because anytime you go to the left, it's negative. Anytime you go down, it's negative. And C looks like it's 1, 1, but it's not. It's -1, -1. The next one is a 90 degrees counterclockwise. Counterclockwise is backwards clock. So counterclockwise is like this. So when we take a look at it for the triple primes, oops, that's supposed to be a B. For the triple primes, for the 90 degrees counterclockwise, A looks like it's at 5, 4, but it's not at 5, 4. Anytime you go to the left is negative. Anytime you go up, up is positive. So it's not 5, 4, it is -5, 4. B looks like it's at 1, 4, but it's not. It's at -1, 4. And C looks like it's at 1, 1, but it's not. It's at -1, 1. Now that you have all of them, all right, now that you have all of them, I would turn your paper back to normal. All right, turn your paper back to normal. And this gets a little bit messed up. Doing it on the board like this. So there we go. All right. When we take a look at it, you have all your coordinates. Now you just need to graph them. I'm not going to spend time recopying them. They're just over there to the right, but I'm going to graph them. So A prime is 5, -4. 5, -4. This is A prime. 1, -4 is B prime. And 1, -1 is C prime. Connect the dots. Notice that our 90-degree rotation, we turned one quadrant. All right, we turned one quadrant to get from there to there. One quadrant going around clockwise. So this was a 90 degrees clockwise. In double prime, -4, -5. This is A double prime. -4, -1. This is B double prime. And -1, -1. This is C double prime. Notice that we went 2 quadrants. Anytime that we go 2 quadrants, anytime that we move 2 quadrants, it's a 180 degrees rotation. Anytime that we move 2 quadrants. And then we have the counterclockwise, all right, -5, 4. This is A triple prime. -1, 4. This is B triple prime. And -1, 1. This is C triple prime. Connect your dots. Notice that we moved 1 quadrant. And this was for 90 degrees counterclockwise. We went 1 quadrant and we went backwards clock. So that is counterclockwise. So just as a quick little reminder, a translation slides the picture. A dilation makes the picture bigger or smaller. A reflection is that flipped opposite mirror image. We could go side to side, or we could go up and down. And a rotation turns a picture. You will need all of this stuff for 6-7.